Now we come to the last thing in geometry this year. And that last thing, of course, is to review Chapter 12 before the Chapter 12 test. So we're going to review in the reverse order of the chapter, starting with the latest material first. The last thing that we talked about was writing the equation of a circle, and that's an algebra technique, and then also graphing it and identifying its center and its radius. So I just want to remind you that the standard form for the equation of a circle is x minus h squared plus y minus k squared equals the r squared. And recall that in the parentheses with the x and y are the opposites of the coordinates of the center. Now, of course, the first thing you have to do to write the equation is you have to find the center, which we're going to do, and then you have to find the radius. So to find the center on this circle, we would locate the middle of the circle. So it looks like it appears to be -4, +2. So there's our center, -4, +2. And then to get the radius, I like to try to count horizontally. So when I go to the right, it looks to me like the radius there is 1, 2, 3, 4. So the radius is 4. Now keep in mind when we write the equation that inside these parentheses goes the opposite of the coordinates of the center point. And then over here goes the radius squared. So don't forget that. When we go to write this equation then, they have a blank provided for us. So we're going to have x, and then the opposite of -4 would be +4 squared. And then for the y, the opposite of +2 would be -2 squared. And then on the other side, the radius squared would be 16. So that's writing the equation of a circle and locating its center and radius when they give you the graph. Another thing that we did in that last section was we wrote the equation when they gave us some information, and then we sketched the graph. Now, in this particular problem, you can see that they did give us the center. So the center was at -2, 1. And I can go ahead and plot that, -2 and up 1. And then they gave us another point. Now, that point on the circle right there is what we're going to use to find the radius, because we do need the radius. I'm going to go ahead and plot that point over 6 and down 1, 2, 3, 4, 5. So that's just a point on the circle. We have to find the radius. And I reviewed with you 2 techniques for finding the radius. Both of them are things that we have used before in geometry. So one of them uses the distance formula, and the other one uses the Pythagorean theorem. I remember from when we were in our traditional classroom, more of you preferred the Pythagorean theorem, so I'm going to show the Pythagorean theorem method first. So for that Pythagorean theorem method, we would think of a triangle that connected C to P. Now by that I mean it looks like I go down 1, 2, 3, 4, 5, 6, and then I go across 1, 2, 3, 4, 5, 6, 7, 8. So I went down 6 and across 8. And the radius is actually this distance right here. So there's my radius. So in the Pythagorean theorem, I would have r squared equals 6 squared plus 8 squared. Now, of course, the other method that I reviewed with you was using the distance formula. To use the distance formula, you need to use the distance formula, so you have to know the distance formula. And in the distance formula, the radius would be equal to the square root of, now if I take the second x would be the x of p, so that's 6, minus the first x, minus a minus 2 gives me a plus 2, and then the second y, which is -5, minus the first y, which was 1, squared. Now here we end up with the square root of, that would be 8 squared plus 6 squared, which comes out to be 100. Now either method is going to give us the same radius. So no matter what, we're going to end up with a radius of 10. Now it's time to write the equation of our circle. And recall that to write the equation of a circle in standard form, we use the x minus h squared plus y minus k squared equals the r squared. Inside the parentheses goes the opposite of the coordinates of this center point. So it appears we would have x plus 2 squared, and then plus, and then y minus 1 squared equals, and then 10 squared on the other side would be 100. So here is the equation of our circle. Now you will have to know that standard form equation for your chapter test. Let's go ahead and finish graphing this one, because it does tell us to graph the circle. The radius is 10, so from that center point, I'm going to go right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go left 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as we saw in our videos, if it goes off the graph, you just extend the graph. You don't change the numbering. I go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we try to sketch a circle that goes through that. It does not have to be a perfect circle in any stretch of the imagination. This time we actually have 5 points to go through. Normally we just have these cardinal points at the top, on the left, on the bottom. Now here's that point P that's extra, and then on the right. And as you can see, my circle is in nowhere perfect, but it's perfectly fine. If we wanted a perfect circle, we would use some sort of technology to graph it. Okay, so those are two of the problems from the last section. Let's take a look at just a few more problems from this chapter. When you look at number 3 here, number 3 was a type of problem that many of you struggled with on the quiz when we took this. And there are 2 ways to do this one. So 2 methods. One of the methods we learned way back in chapter 11. It's actually section 11.1. And that was again using our Pythagorean theorem. So I'm going to show you that method first. Now in the Pythagorean theorem, we know we have a right angle here where the tangent meets the radius. We also need this entire length there. That's called the hypotenuse, remember? And when we put this into the Pythagorean theorem, we would have x plus 2, that hypotenuse squared, equals, and then the other 2 sides squared added together. We're going to go ahead and work that one out completely. Recall that x plus 2 squared means we have to take an x plus 2 times another x plus 2. And then on the right side, x plus 1 squared means x plus 1 times x plus 1. We're going to carry out all of that algebra, so I will multiply x times x, which is x squared, and then I get a plus 2x, and then I get another plus 2x, and then I get a plus 4. On the right side, I have an x squared, I have a plus x, another plus x, and a plus 1. Combining all the like terms, I have x squared plus 4x plus 4 on the right, and on the left I have 2x squared plus 2x plus 1. It is a quadratic equation. We need to get everything on one side, 0 on the other. Since there are more x's on the right, we'll move everything to the right. I'll subtract an x squared, giving me a single x squared. I'll subtract the 4x, giving me a negative 2x. And I'll subtract the 4, giving me negative 3. To solve this quadratic equation, we're going to use factoring. And factoring we've used quite a bit. You'll use a lot more in Algebra 2 for those of you moving on to that, which the vast majority of you are. This one factors into an x plus 1 times an x minus 3. We set each of those factors equal to 0 to finish our algebra. We end up with x equals 1 and we end up with x equals negative 1 and x equals positive 3. Now, the negative 1 will not work in this problem. And that's because we can't have a distance being negative. So this negative 1 will not work. So x equals 3 is going to be our answer. We know that already. But many of you struggled with this, or you didn't remember to use the Pythagorean theorem. So I'm going to show you the other method. The other method is actually why this shows up in this chapter. Now, we have a tangent up here. The tangent would be the x plus 1. And if I extend this the rest of the way through the circle, that's going to be an additional x. Then this whole length right here becomes 2x's plus 2. And that's a secant segment. So we can do this problem as a secant and a tangent. And that was new to this chapter. For the secant, recall, we take the outside times the whole length. And then for the tangent, we only have an outside, so we take outside times outside. Now for the secant segment, the outside is the 2, and the whole length we just discovered was 2x plus 2. For the tangent, the outside is x plus 1. And now we have some algebra to carry out on that side, or on that problem. On the left side, we just distribute, giving us 4x plus 4. On the right side, we just multiplied that earlier. That's x squared plus x plus 1. So we have 4x plus 4 on the left. We have x squared plus 2x plus 1. We need to get 0 on one side, so we'll subtract the 4x, and we'll subtract the 4. And you can see that now it looks just like what we had there. So finishing it, we would get x plus 1, x minus 3. Setting those equal to 0, we end up with the same two answers. And of course, once again, you can't use the negative because we can't have a negative length. Either method will work. So either method works here. Now, that again was one that students struggled with on, I think it was the quiz 12.3. I think it might have been the second problem on that. So we'll look back at that one and see if you had trouble with that, or if it makes sense here, you don't need to look back. Let's take a look at a few more problems here. Here's another one that involves specifically a secant segment and a tangent segment. This bottom one is a tangent segment, and this top one is a secant segment. We need this whole length right here, and that whole length would be the x plus the 15. So if you have a secant and a tangent, we just reviewed that. To do a problem like that, the secant, you take outside times whole length. For the tangent, you take outside times outside. So for the secant segment, the outside is x, the whole length x plus 15. For the tangent segment, the outside is 18. Now take a look at that setup and see if that setup does make sense to you. Let's continue the algebra then. On the left side, we'll distribute the x squared plus 15x. On the right side, 18 squared is 324. We need to move the 324 over. X squared plus 15x minus 324 equals 0. Because the number is so large, 324, I'm not even going to try to factor. Instead, I'm going to use the quadratic formula. You will need to use the quadratic formula at times on your test because sometimes it won't even factor. So when we put it into the quadratic formula, we would have x equals negative b plus or minus the square root, and then b squared minus 4 times the a times the c, all of that divided by 2 times the a. And as you've seen when I work through this, I like to work out what's beneath the radical sign. By the way, that's called the radicand. The radical sign is what many of you refer to as the square root sign. I get 1,521 beneath there. And this, of course, does split into two possible answers. One is when we use the negative sign. So we would have x equals, and do not forget to include the entire top in a parenthesis when you put it in your calculator. And one is when you use the positive sign. Before the radical. So when we work that out, this top one gives me x equals negative 27. When you look at this problem, you can see that actually the negative won't make sense here because we can't have a negative length. When we work out the bottom, you can see that we get x equals 12. So this one would be our only answer. That top one does not apply. Okay, number 5. Number 5 is once again a secant segment and a tangent segment. The bottom one being a tangent, the top one being a secant. Whenever you have a secant segment, you need this whole length. That whole length is going to be if you take the 8 plus the x plus the 3. So that whole length is, I apologize for that, that whole length comes out to be x plus 11. And when you have the secant and the tangent, the pattern that we follow, and these are not formulas, these are patterns you have to learn. For the secant, we take the outside times the whole. For the tangent, we take the outside times the outside. So for that secant segment, the outside is the 8, and we just determined that the whole length is x plus 11. For the tangent, it's 12 times 12, outside times outside. Check that setup, see if it makes sense to you. The algebra here is pretty straightforward. We distribute the 8x plus 88. On the right side, 144. We subtract the 88, 8x equals 56. We divide by 8, x equals 7. So we now have the x. However, they asked us for an additional thing. They asked us for c to e. So to find c to e, we have to plug back in. C to e is x plus 3, so c to e here would be 7 plus 3. C to e comes out to be 10. We've done that often in geometry. Let's take a look at another one. And in this next one, we actually have a secant and a secant. Both of these are secant segments. So this top one, we need the whole length, x plus 12. The 2 and the 10 add up to 12. For the bottom one, the whole length would be 2x plus 9. And when it's a secant and a secant, we follow the pattern of outside times whole equals, once again, outside times whole. The outside on the top one is 10. The whole length we just determined was x plus 12. The outside on the bottom one is 8. And the whole length we determined was 2x plus 9. Distributing the 10, we would have 10x plus 120. Distributing the 8, we'd have 16x plus 72. We'll subtract the 10x on both sides. 120 equals 6x plus 72. We'll subtract the 72. We get 48. 6x equals 48. We divide by 6. We find that x is equal to 8. This one, yet again, asks us to solve for another thing, g to f. So in this case, g to f was 2 times x plus 1. So g to f is going to be 2 times 8 plus 1. G to f then is 17. Again, these are not formulas. These are patterns that you need to recognize, so they will not be given to you on any formula sheet. The next one brings up another type of segment. This was actually the first one that we talked about in this chapter. These were called chord segments. And for chord segments, we had a different pattern. There was no outside. What we actually did was we did first part times second part on one of the chords, right here, will equal first part times second part on the other chord, like this one. So let's go ahead and set this one up. On the yellow chord segment, we have 16 times x. On the blue chord segment, we have 14 times 9. So take a look at that particular problem and see if that setup does make sense. Well, 14 times 9 will just give us 16x equals 126. Dividing by the 16, we get x equals 7.875. It does not tell us to round, so we report that entire answer. Let's try another of these chord segment problems. So in this one, we once again have our chord segments. And that means we will follow the same pattern we just reviewed. First part times second part equals first part times second part. It makes no difference which one you start with. So I'm actually going to start with this one right here. So for that one, first part is x, second part x plus 8. For the other chord segment, this one right here, we have a 6 times an x plus 5. Again, take a moment to look at that and see if that does make sense to you. Let's continue the algebra. On the left side, we distribute the x squared plus 8x. On the right side, we distribute the 6x plus 30. This is a quadratic equation. We must get 0 on one side. We only have x squareds on the left, so let's move everything to the left side. I'll subtract the 6x, giving me x squared plus 2x, and I'll subtract the 30. This one does not factor. So for this one, once again, we're going to use the quadratic formula. Now that quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2 times the a. In our problem, the a is 1, the b is 2, and the c is negative 30. So when I put that into my quadratic formula, I have x equals negative 2 plus or minus the square root, and then 2 squared minus 4 times the 1 times the negative 30, all of that divided by 2 times the 1. And we'll work on what's beneath that radical sign first. So that gives us 124. Negative 2 plus or minus the square root 124 all over 2. We're not finished yet. We have to split that into our two parts. One part is when we use the negative, and let's not forget to enclose the entire top in a parenthesis. And the other part is when we use the positive before the radical. On the top part, I end up with x equals, rounding to the nearest hundredth, which is 2 decimal places, I end up with negative 6.57. On the bottom, I end up with x equals 4.57. When I look at the problem, the negative does not make sense. So yet again, I can't use that one. I must box this answer. Please don't forget you must box your answers. If you don't, I won't know which one to pick, and I will have to take points off, because clearly you don't know which one to pick either, or you would have boxed it. Okay, let's take a look at another segment. So in this one, we have a radius perpendicular to a diameter. A radius perpendicular to a chord, rather. So if you have a radius perpendicular to a chord, it bisects the chord and bisects the arc of the chord. Now, the reason that's important is they've asked us to find the radius here. They want us to find the radius. So let's think about this radius right here, r. We can use the Pythagorean theorem. But to use the Pythagorean theorem, we need to know two sides in that right triangle. Now, fortunately, they've given us the a to f. So they gave us a to f right here. They told us that this length, that I've highlighted in blue here, that length is 20. And we can find d to b right there. And the reason we can find d to b is because of that bisecting aspect. If d to c was given to be 30, that's right here, and it's bisected, then d to b will be 15, half of 30. And now we go ahead and use our Pythagorean theorem. That radius squared will be equal to 20 squared plus 15 squared, since we now know that green part is 15. So r squared would work out to be 625. To solve it, we use square roots. We take the square root of both sides. We end up with two answers. We end up with r is equal to positive 25 and r is equal to negative 25. But yet again, we cannot use the negative here. Radius cannot be negative. So our only answer is positive 25. And once again, you must box your answers. Do not forget that. Okay, let's take a look at another type of problem from this chapter. In this problem, we have yet another segment we talked about. And as you can see, we actually have two congruent arcs. This arc and this arc are congruent. And this is based on the idea that congruent arcs have congruent chords. So that would mean that JS has to be equal to SR. Now JS was given to be 8x plus 6, and SR was given to be 10x minus 2, and that's what we'll go ahead and solve. I'll subtract the 8x on both sides. I have 6 equals 2x minus 2. We'll add 2. We get 2x equals 8. So x comes out to be 4. We now have the x. But yet again, they did ask us for a second thing. They asked us for s to r. So if I want s to r, I need to plug into the 10x minus 2. So s to r would be 10 times 4 minus 2. S to r comes out to be 38. 40 minus 2 is 38. Another type of problem from this chapter. Let's take a look at another type of problem from this chapter. Now, this one is based on the idea that two tangents to the same circle from the same point are congruent. So that means that this blue one right there will be congruent to this yellow one right here. Those two have to be congruent. So AB has to be equal to CB. And now we'll fill in what they gave us. 2x squared minus 5 will equal 13. Next comes the algebra. I'll add the 5. 2x squared equals 18. Divide by 2, x squared equals 9. Finish by taking the square root of both sides. We end up with two answers, x equals 3 and x equals -3. But this time, both will work. Because if I put the -3 in, 2 times -3 squared minus 5, that's really 2 times 9 minus 5. That's 18 minus 5, which is 13. Since they both work, we have to list both answers. So our answers are 3 and -3. And please, again, do not forget, you must box your answers. If there's a blank for the answers, we can just take the answers on the blank as that. But be on the safe side and box your answers as you go through it. You have plenty of time. You'll have 8 hours to take this test. Okay, let's take a look at another review problem. Now we're back to the beginning of the chapter, and this one is asking us to find the circumference. And on this one, we're going to use proportions. Proportions are used anytime they give you information about the part of the circle. This comes from the part of the circle. That angle comes from the part of the circle. And they ask you for something about the whole circle. And in each case, you're going to be comparing the part to the whole. So, for the part of the circle, the angle is 28 degrees. For the whole circle, the angle is 360 degrees. For the part of the circle, the arc length is 42 centimeters. And you've been asked to find the circumference of the whole circle. Proportions are always solved by using cross multiplying. So we're going to go ahead and cross multiply here. We'll have 28c equals, now 360 times 42 gives me 15120. We divide by the 28. You come up with the circumference is 540. So our circumference, 540 centimeters. Don't forget to label it. Whenever they give you information about a part of a circle and they ask you for something about the whole circle, you're going to set up a proportion and cross multiply. We've used proportions throughout geometry, so those are kind of old hand to us right now. Let's take a look at another problem from early in the chapter. Now, in this particular problem, they ask us to find the arc length. Now, to find the arc length is usually symbolized with a capital L. We need the fraction of the circle. So the fraction of the circle would be the number of degrees, 171 degrees out of 360 degrees. That's the fraction of the circle, times 2 times pi, and then times the radius, 17 inches. That's how we find the arc length. The fraction of the circle, the degrees over 360, times 2 times pi times the radius. They've asked us to round here to the nearest hundredth. The arc length here comes out to be 50.74, and then the label would be inches. And that's actually telling us the length of this yellow arc out here. That was the first thing we talked about in this chapter. Let's take a look at another problem from early in the chapter. In this problem, once again, they've asked us for information about the whole circle, and they've given us information about the part of the circle. So once again, we're going to use a proportion. And once again, we're going to compare the part to the whole circle. I like to do the degrees part first. So if you look at the degrees part, we have 73 degrees in the part. Of course, there's 360 degrees in the whole circle. The area of the part is 125 square centimeters, and we're looking for the area of the whole. Take a look at that proportion and see if it makes sense to you. The rest of it involves carrying out the algebra, which is cross-multiplying. 73 times A is 73A. 360 times 125 is 4, 5, and then 3 zeros. We divide by 73. We come up with an area of 616.44, and the label would be centimeters squared. And again, you want to box. In fact, you must box your answers. They have a blank for us, so we could put it on the blank as well. In fact, we should put it on the blank as well. And don't forget area is in square units. It's the units that are squared, not the number. Okay, we're nearly done with the review. Just 3 more problems. So let's move on to number 15. In number 15, they ask us for the area of the sector. The area of the sector, we need the fraction of the circle, which we've already seen from the arc length formula, is 163 degrees over 360 degrees, times pi, and then times the radius squared. So it's the fraction of the circle, which is always the degrees of the sector, divided by 360, and then times pi times the radius squared. In this problem, then, we're supposed to round to the nearest hundredth, so we'll put the whole thing in our calculator, including the pi symbol. And for that area, we come up with 513.50, and the label is centimeters squared, because, again, it's area. And please remember, you must box your answers. Okay, pretty straightforward problem. You will need to know these formulas. They will not be given to you for the test, so you'll have to know them. Number 16. Now, number 16 is a little different in that it asks us to find the radius, and it gives us the area of the circle. So we'll begin with the area of a circle formula. We know what we're going to put in for the A. That's what they gave us, 158 pi. I'm not going to put the units on. It'll just make it unduly complicated to write down. And then on this side, we have pi times radius squared. Now we just use algebra. We'll divide both sides by pi. The pi's, of course, all cancel out. We have 158 equals r squared. And now it's just a matter of taking the square root of both sides. Of course, you do end up with 2 answers. You end up with r equals, rounding to the nearest hundredth, 12.57, and r equals negative 12.57. As we've mentioned earlier and several times in this chapter, the radius cannot be negative. So our answer is going to be 12.57, and the units will be inches. And again, you must box your answers. Very straightforward problem. Even the algebra wasn't too bad there, just using square roots. Last problem on the review. Last problem on the review is actually an application problem. And this is an application problem of a secant segment. This top one I've highlighted in blue is a secant segment, and then a tangent segment. We've done a number of those. So we remember that for the secant segment, we take the outside times the whole length. And what I've suggested to you is that you go ahead and you label this whole length. For that whole length, I'll have to add the x plus the 750. And then for the secant segment, there is only an outside, so we take outside times outside. Okay, time to set it up. For the secant, the outside is an x, and the whole length we just decided was x plus 750. For the tangent segment, the outside's 1100. And you're looking for x, how far you have to travel on that trail so that you get a cell signal. The rest of it is algebra. I'll distribute the x on the left side. I get x squared plus 750x. And on the right side, 1, 2, 1, and then 4 zeros. It's a quadratic equation, so I must get it set equal to 0. Subtracting the 1, 2, 1, 4 zeros, I get x squared plus 750x minus 1, 2, 1, 1, 2, 3, 4 equals 0. Now, something with numbers this large, we would never even consider trying to factor. So we're going to go ahead and use that quadratic formula. In that quadratic formula, I'll have x equals negative b plus or minus the square root, and then the b squared minus 4 times the a times the c. And all of that is divided by 2 times the a. As you've seen innumerable times, I like to work out that radicand first. So I have negative 750 plus or minus the square root. And beneath that radical, I have 540, 25, and then 2 zeros. The bottom is just 2. What remains is to split it into the 2 parts. First part uses the negative. Please remember to enclose the entire top in a parenthesis when you put this in your calculator. 540, 25, 00, all divided by, and that bottom is 2. And then using the positive, x equals negative 750 plus the square root, 540, 25, 00, all divided by 2. When we enter this into our calculator, and it tells us to round to the nearest meter, the top one, I got x equals negative 1537. The bottom one, I got x equals 787. Well, you can't have a negative distance, so we disregard that top one, and our answer is just going to be x equals 787 meters. Again, don't forget the label, and don't forget to box your answer. Okay, that concludes the review for this chapter. Good luck on the test. Remember, I'll be available for help sessions on Monday, Tuesday, Wednesday, and Thursday of the testing week, which is May 18th through the 22nd, but I will not be available on Friday for the help session because you'll have the test open to you, and I can't help you while you have the test in front of you. Best of luck, and hopefully